Assalamu alaikum. Our project is implementation of OMR using digital logic circuits. I am Mahmoud Abtahi, ID 51. Our goal is to construct a functional OMR machine using flip-flops, multiplexer, counter, comparator, and LDR scanner. Then we'll show the correct answer in a 7-segment display. The machine will give us signal if any wrong answer is passed through the scanner. OMR stands for optical mark recognition. OMR has been used widely for evaluating MCQ, which stands for multiple choice question. MCQ is widely used in examinations, surveys, or any other kind of statistics. The main principle of OMR machine consists of two parts: storing answer and scanning and comparison. These are the project outcomes that have been covered roughly by our project. These project outcomes are relevant to our course 304. Here, we have discussed briefly the background of OMR, its current application, and the challenges it has been facing currently. These are the specific resources, integrated circuits, and other electric components that we have used in our project. Our project can be divided by three parts. First, we have to store the correct answer. For that reason, we have used a number of flip-flops. Then we connect the output of the flip-flops to the multiplexer, and then multiplexer outputs to a comparator. Secondly comes a scanning part. We have to scan the answer sheet manually through LDR scanner and then connect the output of the scanners to the comparator. And last, the comparison output part. Comparison compares the correct and scanned answers that it has received respectively from the storing part and scanning part. And lastly, the number of correct answers are shown on a 7-segment display.
Hello, I am John Tudarnath. My ID is 54. Here is the overview of how the system is going to work. Firstly, we store all the correct answers in the flip-flops. Then we shall multiplex it to a common channel to feed it to the comparator. On the other side, we shall extract data from the paper using our hand-built scanner and send the data to the comparator one by one. The comparator will compare two data, and if they match, it will be a correct answer. If they do not match, it will be a wrong answer. For every correct answer, the counter will be counting 1 up, and which will be visible in the 7-segment display. Now we will have a complete walkthrough of how our machine will operate. So our machine is divided into different units. The first unit is storing unit, where we shall store all the given answer in the registers. Firstly, each option of every question is assigned with a bit, 0 for being correct and 1 for being incorrect. We used a quadruple D flip-flop, which are basically 4-bit registers that store 4-bit information. Now here we will assume that one question has only one correct answer, but for multiple correct options, this method works as well. We used 8-bit flip-flop registers here. As we are working with 8 MCQ, we have to store all the 8 MCQ informations. We used a DIP switch to load the data to the flip-flop registers. For example, if the first MCQ has a correct answer at C, the data that will be stored in the first register will be 1, 1, 0, and 1. This is how it looks in the circuit. We added a switch with each of the registers, which works as the load switch for that registers. The DIP switch here will be loading the data to the registers, and an additional switch was used to reset all the registers at the same time. After that, we shall separate all the A, B, C, and D into a common channel by using a multiplexer. Here in this image, all the 8A come here and we send them one by one to the comparator. We have 4 multiplexer here for 4 options: option A, option B, option C, and option D. The number of question we are sending is the question that we are evaluating. If we are evaluating the question number 5, we shall send 5A, 5B, 5C, and 5D to the comparator. And the selection switch for the multiplexer is the number of question that we are working on, which comes from the scanning unit, and it will be discussed later. Here is how it looks in the circuit. With every multiplexer, we have an LED around the corner, which will show the option information of the question that we are currently working on. For all the wrong options, the LED should be on, and for all the right options, the LED should be off. Here in this image, we can see our four multiplexers: multiplexer A, multiplexer B, multiplexer C, and multiplexer D.
Hello, Assalamualaikum. My name is Mohammed Maksud Rahman Turjo, and my ID is 2006053. So this is the scanning part of our project, and for the scanning section, we have used LDR scanners. LDR scanners are basically scanners when work when light is emitted on them. So the output of the LDR scanners and the output of the marks from the previous stage are connected to a comparator, where the comparison between correct answers and scanned answers are done. So as you can see from the picture, we have simulated the LDR scanners using the four circuit diagrams shown below. So this output of the LDR scanners are going to the comparator for comparison with the stored answers. So this is our hardware implementation of the scanner, and we have used a total of 5 LDR scanners. The first one from the left is for counting the questions, counting the number of questions, and the next four are for comparing the answers. Then we go to the evaluation section, and for evaluation we have used a 12-bit counter. So what happen what happens is that the output of the comparator and another output from the first LDR scanner, which scans the number of questions, are sent to the counter. So when the comparator compares the scanned values and the stored values, and if both of them are equal, then the counter counts up, and if they are not equal, then another a red LED will light up showing that the stored answer and the scanned answer is incorrect. So then when the counter counts up, it basically shows that the amount of right answers that have been passed through the scanner. Then if we go to the result section, the result section is basically showing the number of correct answers in a 7 segment display. So the output of the counter is connected to a 7 segment display through a 7 segment display module. So when the counter is counting up, the 7 segment display will also count up. So which basically shows the amount of correct answers. So if we go back to the evaluation part again, we can see an LDR scanner at the below. This scanner is used for scanning the number of questions that has been passed through the scanner. So this LDR scanner's output will be connected to another counter, which will basically count the number of questions, and that will be shown in through using 3 LEDs. And finally, we can see that the output of the counter is connected to a 7 segment display, which will basically show the amount of correct answers.
Assalamu alaikum. My ID is 2006064. So this is our overall hardware setup for our project. In the upper side we can see our flip-flop and our marks assembly, and in the downside we can see there is our 7 segment display and our evaluation unit. So this is our video. আমরা হচ্ছে কি এখন 8টি অ্যান্সারই সঠিক অ্যান্সার দিয়েছি। এখন আর এই অ্যান্সারগুলো আমাদের ফ্লিপ-ফ্লপ স্টোর করা আছে। সো আমরা একটু দেখি। আমরা 8টা অ্যান্সার দিয়েছি, 0 থেকে শুরু হয়ে 1 2 3 4 করে 7 পর্যন্ত গেছে, আবার 0 তে এসেছে, মানে 8টা অ্যান্সারই সঠিক সে কারেক্ট করতে পারে। আমরা এখন আমাদের 8টা এমসিকিউর মধ্যে 3টা এমসিকিউ ভুল দিয়েছি এবং 5টা এমসিকিউ সঠিক দিয়েছি। আমার হচ্ছে এখান থেকে সেকেন্ডটা, ফোর্থটা অ্যান্ড হচ্ছে আমার লাস্টের অ্যান্সারটা ভুল দেওয়া আছে, আর বাকিগুলো সঠিক অ্যান্সার ওখানে লোড করা আছে। সো আমার 5টা অ্যান্সার যে সঠিক আছে সেটা এখানে। আমরা এখন আমাদের 8টা এমসিকিউ। So this is our social impact part. Here we can use this OMR machine to simplify our examination process, and it will also work for our time efficiency and accessibility. So for our future prospect, we can integrate our whole project with AI. That means we can scan our OMR machine, and then by image processing, we can also detect error and also AI driven analysis. So if we want, we can scale our system to our need. If we if we need to evaluate more MCQs, then we will need to use more flip-flops and more marks. And we also can use our project for different types of applications other than OMR machine. We can also use it for surveys, to attendance systems and voting mechanisms, and etc. So this is our conclusion, and this is our references. Thank you.